through the concepts. Then from there, we'll go through the project. So the plan is for us to gain something as fast as possible, because once we get into 2 hours, 3 hours, we all know we'll get tired. So you're all welcome. If you have questions, please, you can chime in at any time. Ask. So let me see that I share my screen. You guys can see my screen, right? Hello? You guys can see my screen. Because I need active communication. It's not a one-way thing. So I need you guys to ask questions, to give me feedback. I don't know if I'm talking to myself. So yeah. Okay. Let's start with C Hello World. So we all know what C is by now. So C is an imperative language, and it's also a procedural language. So the reason why we are starting with C, or why ALX is starting with C, is for us to understand the level programming, for us to understand what's working under the hood, for us to be able to appreciate what our modern languages or high-level languages are doing under the hood, and to be able to answer technical questions that ask you as regards memory management, computer science, and all of that. So what is C? C is a procedural language. What are procedural languages? Procedural languages are languages that move step by step. So you go from step to step, from line 1 to line 2 to line 3 to line 4. So, and it's imperative in the sense that you do not just declare stuff. You have to, the way I can explain imperativeness is, for example, when you have an air condition, there's some air condition where you just press buttons. So those kind of air conditions, you call it as declarative. But for air conditions that have like a knob where you have to turn, maybe to get to 100 or to get to 200, you have to turn and twist until you get the desired temperature. Then that's imperative. So C is an imperative language. It's a language where you have to do everything manually before you get your result. So that's an introduction to C. So the person that invented C was Linus Torvalds. Was one that invented C, and C has different versions. So I think the version we are using, if I'm not mistaken, is version 99, if I'm not mistaken. So you guys can feel free to correct me or to ask a question as I'm talking if you don't understand anything. So yeah. So okay, so I'll just quickly brush up what C is before we go into the tasks. So we know, let me open. You guys can see my screen, right?
Yes.
Nobody's talking.
Yes, you can see your screen.
Okay, so I'll quickly run through. We all know the data types by now, so I don't even think I need to. So we know we have char, we have unsigned char, we have char. The basic ones, we have char, we have int, we have float, we have double. So the ones you might not be very well familiar with are the ones like unsigned. These are modifiers. So these are modifiers. We have unsigned, we have short, we have long. So we have long. So these are modifiers. So there's some times where in some tasks you see something like long int. So this, int takes up 4 bytes. We all know this. So if you need more than 4 bytes, you can either do long int or unsigned int. So int, we all know, takes 4 bytes. And that 4 bytes occupies from like 2 billion characters, from minus 2 billion characters to 2 billion characters. So that's what an int occupies. So you might need more than that number of characters. So you can use long int. So we know int takes up 4 bytes. So if you want to increase the number of, I'm getting an echo. So if you want to increase the number of, we want to increase the size that we want to allocate our values, we can do unsigned int. So if we have something like int a here, we can do something like unsigned int a. So what this means is this one can also take 4 bytes, but it takes only positive values. So remember I said for int, it takes from minus 2 billion to 2 billion.
Okay. Sorry, can you maximize your editor?
My VS Code, this thing, and it's very small. You can as well zoom your. Can I increase the size? I think you can zoom your screen. You should be able to see it. But like, I don't know if I can increase the font. Let me see. I don't know. But if you zoom in on your screen, you'll be able to. If you're using your phone, you can zoom. You can just pinch.
Okay.
So you guys can see it now. I think it's clear now.
Exactly.
Yeah, it's okay.
Yeah, so it's ugly. Anyways. So yeah. Where was I? So I said an int can take from minus 2 billion to 2 billion. So if you have any value greater than, like, it's 2 point something billion, if you have any value greater than that, the int, it will give you an error because int cannot take more than that value of character. So if you want to increase it, you can use unsigned int. That takes from 0 to like 4 billion. So unsigned int is int, but it takes the value from, instead of minus 2 to 2, it takes from 0 to 4. So it's still the same size, but different values. So if you need from negative to positive as well, but you need much larger size, that's when you use the modifiers. You can use like long. So if you do long int, it increases the value from 4 bytes to 8 bytes. So it doubles this 2 bill. It doubles it for you. So like that. So it's 8 bytes. Then you do long, that's 16 bytes. So yeah, so that's that for data types. That's that for data types. Now, I'm just trying to go through basic settings just to juggle our memory. So you know about arrays as well. So you know about char. So to declare a char, you do char A is equals to B. If you want to declare a string, you do char A. So this is how you declare a string and this is how you declare a char. So we also have another data type. It's called structures, but we've not gotten to that yet. So I will now to write functions. Write a function, you just put what it is returning. Let's say int main is a function. So this function is returning int. If it's going to return a char, you change it to char. If it's going to return nothing, you change it to void. So these are like basic C syntaxes that we need to know. So let's look at some of the things we need to know again. Okay, so how does a C program work? So let's write a simple C program and see how it works. So let's write a function, or let's write a program that adds numbers. So I'm trying to lay the foundation for subsequent classes. So subsequent classes, when we get to functions, pointers, and all of that, we have foundational knowledge, and we won't be asking much questions when we get to that point. So what I'm going to say now will help you going forward. So now this is a simple. I'm trying to write a simple program that you can all understand. So sum is equals to A plus B turn sum. So remember, we always have a main function when we are running. So I'll explain C with this simple. I don't know how to write simple programs like this, so I don't need to explain too much, but I just want to explain some concepts. Now, what's wrong? Okay, so okay, so now this is a simple function. What this function does, we can say a function add. Simple function, we all understand what it does. Add int A to B and gives you sum. So this is how the program runs. So when you write a function like this, this thing is inside text.c. So that's the name of the C file. So this is a C program file. This is what is called source code. So this is the source code. This is not an executable file. This is the source code. So this is the function that I've called here, called add. So when I run this C program, what the compiler does is it goes to main first. So main is the entry point for every program. Main is the entry point. So it goes into this main first. Let me see if I can whiteboard a bit here. So it goes into main first, then so what happens is when the program is running, main gets called. Main is the first thing the program gets into. So it goes into our RAM. That RAM is the memory, the random access memory. So the random access memory is divided into partitions. Let me quickly draw that explain quickly. Because we need to understand this before. Good. So this is called this is where the text is being stored. This is the stack. This is where the global variables are being stored. This is the stack, and this is the okay. So now when this function gets called, it is being transferred to the stack. It goes to this point here. So now when this function gets called, this int I, this int j, this int result, they are being stored on the stack. Then I is equals to 2 is being assigned to this int I. J is equals to 4 is being assigned to this int j. Then when you get to this, I said it is a procedural language, so it goes step by step by step. So it first enters into main gets called on the stack. So this diagram you are seeing here is on the RAM. This is what your RAM does. So when this main gets to this stack, int I is going to be somewhere on this stack. It's going to have an address. Int j is going to be somewhere on this stack. It's going to have an address. Int results is going to have an address as well. Now, we've assigned these values. I is equals to 2. So 2 is going to get stored here. 4 is going to get stored here. And remember, I said int takes 4 bytes. So 4 bytes is going to be taken here. 4 bytes will be taken here. And 4 bytes will be taken here. So when it gets to results here, we need to get a value that we'll put into result. So this add function gets called. When this add function gets called, this add function is going to be on top of the main function. So the main function is going to be somewhere. The main function is going to be somewhere here. Then the add function will be somewhere here. So the main function is the function that gets called first. It comes here. So let's say it is going from up to down. From down to up, rather. It's going from down to up. So the main is here, this black one. The add, when it gets to this point here, the add gets called. Now the add function, this function gets called and it goes on top of the main. So when the values I and j gets here, the value I is being copied into add, into here. The value j is being copied into add, into here. And it returns the sum. So the function here returns a value. Now, when the function here is being completed, it gets removed and returns that value back to main. So that value gets imputed into result. Then when you now do printf, you understand how this works. So it prints the result here into this, return 0. So now, if we go back to our code, if we try to run this program, we use a command we all know, known as gcc. Let me save this. gcc text.c. Now, it gives us an error. Printf. It said we should include standard io.h. So now that takes us to headers. So if we've noticed or if we've read about it, we know that we have to include headers if we are calling functions. So this is where we include our header. We include our standard io.h. The reason why we have to include standard io.h is because of this printf function that we are using. So standard io.h contains several inbuilt functions, and we can't use them without including them in our standard io.h. As you can see, when I try to run this program using GCC, we all know what GCC does. GCC does preprocessing, compilation, assembly, and linkage. So let me quickly just go through that. Preprocessing is a stage where it tries to remove things like comments. So let's say I put like a comment here. It removes it. That's what preprocessing does. It removes it. Then preprocessing includes this header file. That's what preprocessing does. So when I do GCC, so if I want to do GCC, so let's do man GCC. Let's see what GCC does before we go forward. Let's do man GCC. So if you want to know what a command does, you can always do man and the command. So that tells you what that command does. So if I do man GCC, it will tell me what GCC does. So if you read the description, it says it does preprocessing, compilation, assembly, and linkage. So these are the 4 things GCC does. So if I go back to my program here, let me save it. If I now run GCC text.c, so what it has done is that it has compiled the program, but let me see the files I have. I can see it from here. So I have a.exe. It compiles it, but it names it as a.exe. You can see it here. I don't know if you can see it. So this file was not there before, this a.exe. But because I use GCC text.c, the default name is a. If you can see, the default name is a. So let me clear my terminal. Now, if I want to give it my own name, I'll do GCC text.c. Then I'll use the flag -o. So like I said, when there isn't any command, use your man. But I also prefer using the help because the help has more flags sometimes. So if you see the man, you can see what -o here is. It's out file. So it outputs that file. Or I can do GCC -help. So I do GCC -help. I can see a bunch of commands. Why is it not scrolling? I can see a bunch of commands. There are some up, but I can't see them. So if you come here, you can see -e, -s, -c, -o. So -o here places the output into a file. So if I want to give the file my own name, I'll use -o. So I'll do GCC text.c. That's my text, my C file, and I'll output it as whatever I like, but I'll use text. So you can see the text.exe here. So this is an executable file. We don't know what .exe means. It means that file can be executed. So it has created the .exe. So you can see I cannot read anything because it is a program. It's not a file again. This is a source code. This is called a source code. So when we compile it, it becomes a program. So this text.exe is a program. So I have to now run that program to get the value of this printf. I have to now run this program. So to run the program, I'll just say in my current folder, I'll type the name of so I don't need to put the extension because it will just know that it's. So once I press enter, see it runs the print command, the printf command. 2 + 4 = 6. So that's how a simple C program is run. It's not that complicated. So this is the source file. You compile it, output the file into whatever name you want, and you get your results. So now, in consequence tasks, we discovered that we usually write the programs in one file, and we don't know where the main.c file is and the main.h file is. So let me try to explain that. So we usually create a main.h file. So the main.h file, the main.h file is the header file. This is the header file. The text.c file is the source code. So now this is the header. This is the header. This is a standard header. It has been created. We are just importing it. C recognizes this header, but we can create our own header. So I want to create my own header called main.h. So how do we do that? I think we know how to do that. So I'll just type it. So we do something like if ndf main h define. Then we end it. I think end this, yes, end this. So inside the main.h, what we usually do is to put the header function we want to use. So this is the function. We just copy the header. This is the header of the function. So we copy it and put this in our main.h file. So what this means is we can use this function as far as we call the main.h. So I would just quickly explain that. So let's say I can copy this. I can copy this function, create a new file called add.c. So when they give you a task, they will say you should create a script that does a command. So what you usually do is just to type in the function. Type in the function. So this is an example of a task that ALX will say we should do. Create a script that does something. So let's say create a function that adds 2 files. So now, this is the function that adds 2 files. Very good. So this is our main.h. It contains the prototype. Now, when we go to our text.c, let me rename this file to main.c. So this is our main.c. So our main.c only contains the main function. So when we are compiling, the C program just comes to the main.c and it first looks for main. Wherever main is, it first looks for main. So it comes to this main.c file and enters this main. So now if you look at this main function, we have an add function here, but the add function has not been defined in this script. So how do we get the add function that we have put here? Here. So that's where the main.h comes into play. So what we do is, because we've defined the main.h, we can import it here just the way we imported this standard IO to use the printf. So we'll do main.h. So what this does, obviously, is to take, so this main.h is like a middleman. That's what it does, like a middleman. It just takes this function from where we've defined it and gives it out to whatever script needs it. So this script obviously needs this add function. So it takes it from this main.h. This main.h gives it from this add.c. So that's how most of our programs on the portal works. So now, how the checker checks our work is it uses, let me see the command. Okay, yes, this is it. So this is what it uses to check our work. Something like this. Might not be consistent, but something like this. So it uses this command to check our work. Now this is GCC. These are flags. These are all flags. They all mean different things, but from my understanding, what this flag does is to ensure that our work is like we cross our T's and dot our I's. So it's not going to skip any error. Like that's why some people complain that when they run their program on a particular, maybe they use code block, it runs, but when they run it on the checker, it does not run. People have different. is because the checker is using strict commands to ensure that no error is being bypassed. So what we do is in this command, I'll just clear it. So this command, like I said, all these are flags to do different things. Just I'm sure most of it is for error checking. Then we'll put our own command. So we know we have our add.c. We know we have our. So I'm teaching you how to run your own program without using the checker. So you have your add.c, because sometimes when you notice that sometimes when you use the checker, it will not tell you what the error is. So you can run it yourself to determine what the error is. So you do your add.c, you do your main.h, then you put your main.c. Then you output it to whatever name you want. Let me say add. Then I run it. Okay. It says there's an error here because of the comment. So the comment, this is what I'm saying. Because I use the GCC flag that ALX uses, it's giving me an error. But this error would normally run if I don't use that flag. Look at, it's saying the comments are not allowed in ISO C90. So this C90 is a C version that I am using. But ALX, if you check the command I used, they are using version 89. That's what this is. So that's why when you run your programs in other IDs, they might not run, but it will run here. Hello, Victor, you want to say something?
Okay, yes, I'm with you.
Okay.
Yeah. So on the comments,
Okay.
I don't know if it's I don't know if C has a specific way of writing comments. Okay, or I don't know if that's a Betty just because of the Betty standard. That means you need to have that after the what do you call it, /, then you need to have asterisk then /, then you close it with asterisk then /, something like that.
Yeah, that's. I think they're like. See, people have like different. So this is a warning, not necessarily supposed to be a warning, not necessarily an error, but he called it an error because of the flags we've put. So it's not a strict thing. So you can write a comment like this. It's just based on what ALX want us to use. Like they have, like different companies have their own standards, how they write their code and all these things. So maybe based on this ISO C90 standard, they don't want you to write the comment like this. You get? So something like that. So that's how it is. So if I let me try to change it to the normal comments we've been using and see if it will pass. It should pass, but let's see. See, I got no errors. So it's because of that comment. So that's why I want you guys to just note that. So when you're getting errors, maybe you run it on code block or you run it on VS Code or you run it on an online ID and it runs, and you try to run it with your checker and it doesn't run, you should know that the small things like this that affect your work. But the checker is being extremely strict. So once I've compiled my program. So once I've compiled my program, I can run it. So it gives me my answer. So it takes all these files that I have here and it compiles it and it gives me my answer. So that's how like a basic C program works. So you can have all your scripts on one file like I initially did on a main.c, or you can have it spread out across files. So I think that's C basics covered. I think we've covered C basics as a concept.
Please, so what's inside your add.c?
What's my add.c? Okay, it's my add function.
Okay, like the function you are asked to write.
Yes. So if they give you a task, so I just did my add.c function in a file, in a separate file called add.c.
Why the main.h is the
The main dot each is the header. Yeah. So that's like a middleman passing the function around. So you take the function from here to be used by other scripts.
but you can actually merge main.c and add.c.
Yeah.
Like they will be
If,
fine.
yeah. Were you here in the beginning? That's what I started with. I did everything on one script
Yes, I just
before I
want to
separated.
be. Yes, I just
Yeah,
want
yeah,
to
yeah,
be.
yeah, 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 yeah. You can do that either ways. So the reason why we separate the files is because you can have large chunks of code. So when you put everything on one file, it becomes very difficult to read. So they're teaching us industry best practices to always separate, always have as much files as possible. So it becomes easy to read. So people can easily follow your code. So that's just it.
Alright.
Yeah, so I think we are good. So what Betty? Let me just quickly. Betty is a linter. Betty is a linter. So what linter does is to ensure that you follow like either your own set best practices or the default set best practices. So when you are working for companies or you are working for organizations, they will have their own linter style, like their own indentation style, their own white spacing style, their own spacing style and all. So we are using Obertin's linter because we're obviously working with Obertin. So Betty is their own linter. So it enforces the style of our code. So they're just trying to introduce us to industry standards, basically. So it means we just need to follow how they want their code to be structured. So that's what Betty does. Betty is just to enforce that our code looks a certain type of way. So that's what Betty does. So I think see hello world has been covered. Okay, so should I quickly run through the tasks, or is there any particular task you want me to? I think yeah. So is there anyone that has any particular question? I should just run through the tasks. The tasks are quite simple.
Okay, there is something I want to ask. In this
Okay.
add.c file, this function you wrote
Yeah.
after the prototype, you wrote int equals to 0.
Yeah. Yeah.
Why 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 did you write it like that? Why did it equals to 0? Or aside it?
No, okay. Before I had the full function, I can do this. I can just do in sum. It doesn't mean anything.
That's exactly what's confusing me.
No, it should not confuse. It doesn't have to confuse you. It's because of the way I wrote the function initially. I didn't change it, but there's nothing. There's nothing special. There's nothing special. So because I did in sum is equal to 0, I will just initialize. You can initialize it like this, or you can initialize it with 0. But once I've done sum is equal to a plus b, it overwrites what is in that sum. So even if I say sum is equal to 0, as far as I've done sum is equal to a plus b, it overwrites what is in that sum. So it doesn't really matter.
All right.
Yeah. So um, let me quickly go through the tasks. The tasks are quite simple. Yeah. I'll quickly run through it so I don't take much of our time. So the first one is to write a script that runs a C file through the preprocessor. So I think I was explaining. Okay, not here, not here. Let me try to explain the task with a diagram. Okay, so the first task. What's that noise? What's that noise? Oluchi,
Good evening, Samuel.
good evening. What's up?
Oh, I can't say. Please, did you guys record the when you started?
I think it's being recorded. I think so.
Okay.
Yeah.
I entered late. Just came back from school.
Yeah. So, um, So yeah, let me quickly run through the task. Zero processor. Zero preprocessor. The task is to write a script that runs a C file through the preprocessor and saves the result into another file. So this is not a C task. This is a Linux-based task, but it's based on C. So so a compiler, so a compiler is something like this, so it has or how will I write it? Okay, let me just write it in terms of text. So a compiler is a processor this format. So a compiler is preprocessor compiler what's the next one again? Assembly and linkage or whatever. A linkage. So what happens is this: when you run your GCC, this is what your GCC does. This 14. If you run your GCC without any flag, it runs this 14. So now what happens is when you do GCC, it takes your source code. Let's say our source code was what? Let's say our main.c. It takes your main.c, then then it enters into the processor stage. So in the processor stage, it removes header files and all of those things. So this question is saying, write a script that runs its C file through the processor and saves the result in another file. So it's just going to run through this stage. So there is a flag. If you remember when I did yeah. So there is a flag for running it through the processor. That's the -e flag. Do you get it? That's the -e flag. So the -e flag is the flag for preprocessing. So what we do is we just do write our script, obviously. So our script will be shebang bin bash. So we know what this shebang bin bash does. It just tells the whatever is running our file that it should go to that bin bash, and it should so once it goes to that bin bash, it now recognizes our file as a script for it to run. So this bin bash command is just like it's like a protocol that tells the shell what our file is and how to run it. So under that, you do your GCC. So the flag is -e. Then the file is $C file. Then -o is to output, if you can remember. So you output it into a name called C. So that's the answer to this one. So for number 1, it's almost similar to number 0. It says write a script that compiles. Yeah.
Sorry to interrupt. This
Yeah.
processing, compiling, assembler, whatnot.
Yeah.
Can I do it myself? Like without doing GCC, I'll process it first, then I'll compile, assemble, and then can I do that
Yes.
myself?
Yeah, if you want to go stage by stage, you can do that. So you just run. So this is the command to do processing. So if you just do GCC without this flag, it does everything for you. So if you start adding the flags, you are saying, okay, GCC, I want it to only do processing on this file. Don't do compiling, don't do assembly. The reason why you might want to do this is because you might have your own like program that will run the others for you, but you just want GCC to do this one for you.
Oh,
So, but generally speaking, you will not need to do this. So, this is for preprocessing. Yeah. So the next one is a script that compiles. So we'll come to this one here now. So obviously it's the same bin bash stuff. Then we do GCC. Then for compiler, if we go to our help to compile and assemble but do not link is -C. To compile only but do not assemble or link is -S. So what's the question asking us? Write a script that compiles a C file but does not link. So what's that? So is this -S? Compile a C file only that does not link. That does not link. So there are two: compile and assemble but does not link. Compile
How you
only.
get this page?
This page, yeah, you run. Let me close it. So you can either do. So if you do man GCC, it gives you some commands, but it does not give you all the. It gives you the flags here, but look at the flags here, but it does not tell you what they do. So you can either do this, or you can do GCC -- help. So GCC -- help does this. It gives you more flags to use. So that's it. So this one now compiles the C file but does not link. The output file should be named the same name as the C file, but an extension .o instead of .c. So when you use -C, that's the compiler. That's when it gives you this output, this .o extension instead of .c. So our command will be gcc -c $C file -o. No -o, because we're not outputting it to anything. You didn't say we should output it, you also should write the command. So this is the answer for this. So for assembly is the next question. So one thing I've noticed about these tasks are, like, if you go back to them after a while, maybe 4 tasks, after you've done 4 projects ahead, if you go back to them, you discover that they become simpler. Like when I was doing this initially, the first time I was like, what's all this? But when I went back to them, I'm like, okay, it began to make sense and it became pretty much simple. So yeah, so for the assembly task, it says write a script that generates the assembly code of the C code and saves it in an output file. So this one is pretty much straightforward as well. So that would be -S. That would be -S. Assembler. So -S is for assembly. Is it for assembly? No, I think this one is for assembly. Compile and assemble should be -C, and I think the other one should be -S. Yeah, so let's go to the next one. Name. What's the task supposed to do? Write the script that compiles the C file and creates an executable. So this one is what we've pretty much been doing. Just you should compile the C file, no flags, and give it the name C is fun. So this one is straightforward. Just do GCC, the file, then you output it. So you can either use this, output it, C is fun. Yeah, so that's straightforward. So for number 4, it says write a C program that prints exactly this. So this is a string. This is called a string, followed by a new line. So it says we should use the function puts. What puts means is this put, that S is string, put string. So it puts string to the standard output. So the standard output is, this is our standard output. When you run a program, what it gives you is your standard output. So put S. So it says you should use this function, put S. So what, when they say you should use a particular function, you don't know what that function does. You do like I've always said, just do your man put S. So it tells you what it is. If you read, okay, this put S, put S. So put S is a function that takes in a character or a string. So what does it do? Put S writes the string S and it clearly new line to standard output. So like I said, standard output is your command line output here. So that's what S does. So they're pretty much straightforward task as well. So what we are supposed to do is we are supposed to write. So this one's a C task. The rest were like command shell tasks. So this is a C task. So we are supposed to write a C program. Let me just write it called for-puts.c. Then, so because we're using this puts is a standard function that you can only find, I think, standard io.h. So it's included in standard io.h. So you just do include standard io.h. So if I've included this, that means I can now use that puts function. So obviously you have to have your main. So we can do void because we're not returning anything, or you can do void because we're not returning, or you can do main, or you can do int but return 0. So it will be int. What's the name of our function? Name of our the name of our function is main because we are going to call it directly from main. So main is not taking in any argument, so we put void. So we write our function. Our function is, what does it do? We're using the puts now. So the puts, whatever you put based on this thing, say write the string S. Based on this now, it means we should put in our string or our character. So that's what we put here. So I can just say, so I want to put this, I can just copy this and put it inside. So whatever you're printing with puts, you have to put it inside double quotes. So I can put it here. And so you can see that. So everything you are doing must be in double quotes. Now you can see that because there is a double quote in front of this one, the formatting is even poor, telling you that there is an issue there. So you have to escape this one. So there's an escape character, and that's the backslash. So the backslash means if you are using, that's why if you are using a good editor, it will show you easily. So if you can see it, if you can. So the reason why we are using Vim and Emacs is so we don't get all the benefits and we need to code like properly. But if you can see it, you can see that the color is different. So what that means is escaping that double quote. So it's only the double quote that is outside and the double quote that is inside that is recognized. So what is inside this place? So this backslash, when you put it, it will not show, but this one will show. So that's how you do it to escape any character. Use \n. So then I think that's all. So this would work. This should work for this number 4. So for number 5, what's number 5 saying we should do? Print F. So it says we should use print F. Let me just edit this one to number 5. I can rename it to 5 print F. Print F. Print F.c. So we should use print F. So if you notice, after this first hello world task, for the other tasks, we're not using standard io.h, we're using puts.char that Obertin had created. That's because they wanted us to really understand what's going on. But in reality, you just use your standard.io and use your printf or your puts or your put.char. So we're using standard.io here to use printf. So we just do printf, and we'll copy what is here into here. I think that's all. So it's a simple, followed by a new line. Okay, they say followed by a new line. So we know how to do that already. Just do so escape character n. So it's not going to read that n. So when you do escape character n, we'll tell you that it's a new line. So consider most of these tasks are very simple. So that's 5 print f.c. So now this number 6, it says write a C program that prints the sizes of various types on the computer it is compiled and run on. So it wants us to. So if you look at the example here, so if you don't understand the task, what I usually do is I'll go and look at the example here to really understand like what's going on. So you can see they want us to print something like size of a child equals to 1 byte, size of a child equals to 4 bytes. Hello? Hello? So we can see that size of a byte is 1, size of a child is 1 byte, size of int is 4 bytes, and so on and so forth. So they want us to do that for. Okay, they say we should print the exact same output as in the example. So they want us to do all this. So let me just, I think it's on my, let me just go to my my repo and break it out from there. So I can just paste all this. So it's pretty much
Sorry, please, I have
straightforward.
a question.
Okay,
Yeah.
go ahead.
In the previous tags that you just did now,
Yeah.
you didn't return any value. You didn't put return 0 or something. I don't know.
Yeah, okay. Oh, I've closed it. Okay, let me. So yeah, so I was saying, for example, in this task now, you return 0, Abby.
Yes.
This one you are saying, yeah. So you're returning 0 because you are returning integer. So if you have integer in front, you have to return a number. You have to return an integer. Because what int means is what this int is saying, you must return an integer. This function must return something. So because I was not returning anything in that one, so you can either do it this way or use void. So void means I'm not returning anything. Do you get?
Okay, yeah, I got it.
So I used void. It means I'm not returning. I don't want to return anything. So it's the same thing. It's just different ways to. There are different ways to kill to skin a cat in programming. You don't have to be strict. So they're both the same thing. It's just different. So this one, when I put integer in front, it means I must return something. So that's why I'm returning 0. So yeah.
But you said if you want to return an integer, does it mean you can return 1? So
If you return 1, it doesn't mean anything. Because what it will show because you are not returning, you are just returning it here. It won't show, you're not printing it out. You get. So if I run this program, I put 1, it won't show, but it's returning it to here. So what I need is to print these values. Do you get? If I return this 1, it's just returning it. It's not returning to anything. Unless I have a function on top of it that returns 1 to this main. You cannot say, okay, it's returning to this main, but this one is not returning. So this return 0 is like end. It's the same thing as end. It's the same thing. The same thing as end. Yeah. So yeah, for this task, print the sizes of here. So size of char, size of int. So understanding the size of will also help us when we get to malloc and all those stuff. So size of tells you the size of your data type. So the reason why we use size of instead of hard-coding the data type is because on different computers you can have different sizes. So that's why it is recommended to use size of. So size of char, we all know that size of char is 1 byte, size of integer is 4 bytes, and size of float is 4 bytes and all of that. Yes, but on a very random system, it might not be so. So that's why it is advised to use size of. For example, for pointers, we are doing size of pointers. A pointer can be 4 bytes on 32-bit system and 8 bytes on 64-bit system. So that's why you are required, or it is necessary for you to use size of. So like you might want to use the size of the char in your code. In maybe if you are writing, if you want to allocate a space for char in your code. When we get to malloc, you understand. You want to allocate a space of say 1 byte for char. So you can, if you put 1 byte directly, you have a problem. And if you put 1 byte directly, you might have a problem if it is not 1 byte on your own particular system. So that's why it is advised for us to use size of. So size of gives you the size of data type you put into it. So this should give us 1 char on my system. This should give us 4. I say 1 char. Should give us 1 byte. Should give us 4 bytes. Long int, like I explained in the beginning, means you are increasing your integer by 2. So long int should give you 8 bytes. So this should give you 16 bytes. Float should give you 4 bytes on my system. So if I run this, let me just try to run this. Just to see 5 points. Let's see. So we put slash. Yeah, so you can see size of char is 1 byte for this one. Size of int is 4 bytes. Size of long int is 4 bytes. You can see. Size of long int is 8 bytes. You can see. Size of float is 4 bytes. So I don't know why size of long int is 4 bytes here, but this is why I'm saying like you don't need to hard code it. Like in a text, I saw size of long int is double. That's 8 bytes, but here it's telling me 4 bytes. So that is why it is always advised. Let me see what is in their own example. I think it's the same as well. 4 bytes, 8 bytes, 4 bytes. It's the same. So that's for this particular task. So for number 7, it's number 7. I think number 7 is an advanced task. So for advanced tasks, when you have an advanced task, first thing you should know that it's advanced for a reason. Like you will need to do like extra research, like specific research to be able to get the answer. So this particular task is write a script that generates the assembly code, Intel syntax of a C code, and save it in an output file. First of all, what is Intel syntax? You get like what's Intel syntax? That's what you need to ask yourself. So it's a simple, like if this Intel syntax was not there, I know that I'll do like I explained here. If it is assembly code, I think assembly code is minus S. I think it's minus S, minus C. But if it's assembly code, I know I'll just run this. I think it's minus S. I think it's minus S, minus C.
Minus.
Yeah?
Minus C.
Yeah, so for assembly code, if I want to run it normally, I'll do this. But the condition here is to use Intel syntax. So, I mean, this is where you use your Googling skills and Google. So, first of all, I would come here. I'll just come here and Google. So, Stack Overflow is usually a good place to find solutions. So you come here. So I'll go to the one that is being upvoted the most. So obviously it says, how do you use this to generate assembly code in Intel syntax? So it says use this, and it has been upvoted. So it's most likely correct. So I'll just take this. I'll copy it. In fact, I'll just take the whole command because this is C minus S. This. I'll just copy it. Then I know that for my task, I'll just paste it. So I'll go back. I think that solves that. No, okay. The variable name will be saved in the variable $C file. So I'll output it. No, that's where the variable, that's the file I am working on. So I'll just do C file. So that's that for that question. So for the last one, what was it again? So the last one is to write a C program that prints exactly this, followed by a new line to the standard error. So the one, when we use printf, it was the standard output. So now it wants to write a program that prints this to the standard error. So I know that, first of all, I don't know what this is. I'll go and Google what this is. You are not allowed to use any functions listed in the name section of the man printf. So they don't want us to use printf or puts. Your program should return 1. Your program should compile without any warnings when using this. So we know that we cannot use, so if I wanted to do this normally, I'll use printf. But first of all, they said printf prints to standard output, not standard error. So to print to standard error, I'll Google print to standard error. Let me check Stack Overflow. They're using printf. That's what they're using. But they don't want us to use printf. So if you remember the Pucha source code. So the only way I could understand that task was when I saw the Pucha source code. So that's why I was saying initially that some tasks you will not understand until you've done 3 or more tasks. You will now understand the task before. So the way I was able to understand was when I saw the Pucha source code. So the Pucha source code I saw is here. So the Pucha source code is here. That's the Pucha source code that Obertin does is here. The Pucha source code that Obertin uses is here. So if you can see, the Pucha that we have been using, the underscore Pucha, takes the write function from unist.h. So this is the header file, it takes the write function. So what this write function does is that it takes the address of the string or characters and prints it to 1. So 1 is standard output. So if I take this function now and Google it, write function, not necessary.
I don't understand what you just did here.
Okay, so you understand the task. The task says we should print this without using printf or puts, right?
Yeah.
So that means we cannot use these functions from standard iu.h. So you will research how to print stuff without using standard iu.h, functions from standard iu.h. So there's another way to print stuff using the write function, which can be found in this header. So this is not standard iu.h, this is unistd.h. So the function is this function.
The Pucha function.
No, not the Pucha function. The Pucha function is using this function. So the Pucha function we've been using is using this function.
Okay.
You get it now, it's using that function. So now I'm trying to Google what that function does, so that we can explain what.
Go right ahead and use Pucha to print the stuff.
Because the task says we should not use Pucha. The task says we should not use Pucha or puts is there. That's why it's an advanced task. is there. It says do not use any function listed in the name section of the man printf. Or so if you do man printf, you see put there, you see different functions there, and most of them fall under standard io.h. So you cannot use them. So we have to look for a way to now print this without using printf, without using put, without using. I remember in this task, we've not started using that underscore pucher function.
No, I think that one we created it ourselves.
Yeah, so now they're trying to show you how to print without using standard io.h. So here comes the right function. So this is the right function according to Wikipedia. So does this explain itself? This does not explain it. Let me check this. Yeah, so the right function, this is the right function here. The right function takes 3 arguments. It takes where you want to print it to. That's file des. This file des, I don't know if they defined it here. So, okay, they didn't define it here, but I can explain it. I don't know if they defined it here. Okay, file des is the first argument here as well, but the one is fd. So fd is the file descriptor, or fd. So fd, it can be value of 0, 1, or 2. So if you write your right function, it takes in 3 arguments. Huh? No, this is the last task. Is it number 8? I don't, let me check. Number 8, yes. Number 8.
Why you using okay? The right function is what you want to use instead of printf or print.
Yes, because we are tasked not to use it. So there's another function called write. So that's what I'm trying to explain. So write, if you look at the documentation, write is gotten from include this. So I'll just copy it and put it here. So this is the header file for write function. So I will use the write function. So the first argument, it takes in 3 arguments. The first argument is file des. So from Wikipedia, it says file des fd is the value 012, which can be given for standard input, standard output, or standard and standard error. So standard input means you are taking in a value. So when you type in something in your command line, that's like standard input, or you input something to a function, that's like standard input. Standard output, which is 1 here, is your terminal. So when you run a program and it gives you an output, let's say you run a program that does 2 plus 2 equals to 4. When it gives you that 4, it shows in your terminal. So that's standard output 1. So 2 is standard error. So if you want to write to standard error, maybe you want it to give you the error that is associated with that program that you are running. You put 2 in your first argument. So the second argument, buffer, points to a character array with content to be written to the file pointed to by fd. So the second argument takes in what you are imputing into the right function. So that can be a string, that can be a character. So, and that's usually the address of the character. So that's address C. You're getting it now. So the last one is the end byte. Specifies the number of bytes to be written from the character. So that's the number of bytes that is in this character here. You put it here. So if you go back to our question, so if you want to know the number of bytes that is there, you count it. I don't know. I think.
But you put 1, if you want to standard, I'm not writing for standard error.
Okay, it's a standard error, so that would be 2, not 1. You get it now? That would be 2, not 1.
The
They are pattern C. They are pattern C.
What are we doing with it?
So the pattern C is the address of this string. So I'll create a variable that will hold this string. So I'll create a char, I'll call it maybe C. I'll call it char C, and put this. I'll now say is equals to the string. I'll just copy what is there and put it here. You get? So I'm saying this. So from here now, I'll just put the value of C. So remember your pointers. Once you put your string, so you can see how everything is connected. You remember your pointers. You put your C here. Your C means the address of the first. So it takes the address of the string and inputs. So the address of the whole string that is going to be put here. Do you get it now? So here now, you now take the size of the string that you are expecting. So if you count it, I think it's up to 59. So you put 59.
How are you going to count it?
Huh?
How are you going to count it? What's the count?
I can't hear you.
How is it counted?
No, you can count manually now, or you have a text editor, you can just do this.
Are you counting one letter at one by
Yeah, one character each. So a space is a character too.
What about the quotation sign? Are you counting it?
No, the quotation sign is not there. So you add one to it, too. You add one to it because there is a null. If you remember, there is a null. So you add one to it. So that's what we put here. So this writes it to standard error. So this will give you the answer to this one. And they say you should return 1 after. So you return 1.
Can you
So
bold
that
it? I want to screenshot it.
I should
As like
increase this.
Yeah.
Okay. You know you can pinch your screen, but
Can do what?
like you can zoom it on your screen too. So, but yeah, can you see it now?
Yeah.
Yeah. So everything will be inside a main function. Obviously, everything will be inside a main function. You can check your yeah.
This where you like where you initialize it.
Sorry, I'm not hearing you.
I said where you initialize the C, which are
Yes. So yeah.
Okay. I'm saying it's from the question.
So you can see that from the formatting, it's giving me an error here. It's because I did not put slash here.
To negate this quotation.
Yeah, so it's to escape this one. Yeah, so that's it. So I think we've tried for today. We've spent more than we are supposed to. So yeah. So is there any question? I think we've tried for today.
Yeah, it's not like a question. Can you please explain why you have to? I didn't get it.
Why I have to what?
After the brackets, have to.
Sorry, your line is breaking. Can you repeat it again? Repeat what you said.
Can you hear me?
Yeah, I can hear you now.
I said, why did you have to here after the brackets?
Oh, you're not here when I was explaining it. So the right
Yes.
function. So the right function here, if you check Wikipedia for the right function, look at this right function here. So it takes in 3 arguments: int fd, const void, blah blah blah, and this. So the first one is a file descriptor. That's value 012. So you can either put 012. 0 means standard input. That means it's taking in value. Obviously, it cannot be standard input because standard input means it's taking in value. 1 means standard output. The putcher function we're using is standard output. That means you are printing to the command line. So when you run a program and you do printf prints to standard output because you can see it on your command line. So the last one, 2, is print to standard error. So the question says we should print to standard error. So that's why we're using 2 there. You get it now?
Yes.
Yeah. So the second argument takes in the address of the string or the buffer you want to put into there. So C points to the address of this string. You remember your pointers very well. C points to the address of the string.
Because it's a string, they didn't put the ampersand sign.
Yes, you don't need to put it exactly. So 59 is the size of this string. So you put the size here. So that's it. So this now writes this string to standard error. So that's it. So I think we've tried.
Can I ask one question?
Okay.
Hello. So it's outside this.
Okay.
Outside this. So I was trying to write a C program.
Okay.
And I was trying to use call point function by reference everything. So
Okay.
let me open the
What are you
function.
referencing? A string, a pointer, a function, an integer, what?
So I was just referencing an integer. It's not a
Okay.
pointer. So I wanted to
Okay.
swap numbers. I did the pointer one on swapping numbers and it worked. Then I wanted to swap numbers, but I just declared the variable but in the function. There was no pointer or whatnot. But after the function, when I got to the main C file, I
Mm.
called the function by writing the function name. Then I put in the actual parameters inside the parentheses, and I did print f, so
Yeah.
it prints the values after the swapping, but it didn't print. It printed exactly as it was before.
I'm trying to picture what you are saying, but I don't know if I'm picturing it
Don't
here.
worry, I'll screenshot it and
Yeah,
send
just
it to you.
yeah, exactly. Just screenshot and send to me. I'll be able to figure it out from there. So,
Thank
yeah.
you.
So yeah, you're welcome. So yeah, if you have no other question, I think we can call it a night.
Hello, please. I have a question.
Okay.
Okay, thank you. Yeah, please. From this, their example,
Yeah.
uh, I don't think I think they are making use of something like echo Greek print function, something like that. I don't know. I don't understand.
Which are you talking of this last question we just saw?
Yes, this last one, this Unix is
Okay.
basically
So okay, you have a solution that is different.
no. I'm talking about from their own example.
No. This okay. You're talking of this gray part, Abi.
Yes.
Okay, so this gray part, when you see this gray part, what they're trying to do is they're trying to like show you the process of running the program. So now if you look at it,
Okay.
this GCC blah blah blah, you know the file we created is 101 code.c. So they're saying if you
Exactly.
run, they're trying to show you what you should be getting. So if you run this GCC, if you compile this one and you run this code, you should print this value. So what we are saying
Out.
is
Okay.
when you run this program, you should print this thing out. That's it. So
Okay.
this echo dollars is returning this one that we have here.
Okay.
So this echo has nothing to do with it. They're just trying to confirm that you returned one here. That's all.
But why are they making use of print function and print f and put? And in the question, they said we should not use that.
You know, this one they're
We tried.
testing. This is just all these are just tests. They are tests. They are running
Okay.
tests.
Okay.
It doesn't have to do with the main thing is to write your program that prints this. Then from here,
Oh.
what they did is so cat q. So when they do okay, so from here now, what they try to do is like this code that try to output into this queue. So when you do cat q, it should still print because cat
That
obviously
same
prints to
strength.
standard output. So it prints this.
Okay.
So grep print f this. I'm not really sure what this does, but I think it takes print f into this and it takes put into this. So this is like standard input into this is like input into this. But this you can see this does not print anything, so you don't really need this. They're just trying to show you that you can run some tests on it. But the main thing is that when you run this and you do this, you should get this and this.
Okay. Okay.
Yeah.
Thank you very much. Really appreciate this explanation.
You're welcome.
Sincerely. Yeah.
Yeah. So I think we are good. Victor. I don't think Victor is available. So So yeah, I think we are good. The absence of okay, Victor is here. Okay, Victor, I think we are
Yeah,
done.
yeah.
So
Sure. So thanks, guys. Moving forward, definitely our sessions will keep getting better. Um, every instructions for every instructions like I was sharing with the moderators earlier. Everything you need, like now, you just handle the session. Moving forward, anybody can come up, can you can walk up and okay, let me handle this today. Like it's so how it was. It's going to be a collaborative um, stuff. All right. Let me come here. Okay, you're not sharing your screen. I believe anybody who is really serious has already, because very soon we'll get to a part whereby we'll be sharing some specific um, resources on the, what do you call it, on the Google Classroom. So I believe anybody who is actually serious with this stuff we're trying to do. Can you see my screen? I hope my screen is clear.
yeah, I can see.
Yeah. So everything we are doing now, these sessions I just finished having, I'm recording it. So very soon, once uh, as we're ending it, I'll be uploading it under this CLO one because this is what we're doing. Then I'll open up the next concept, put um, the next important objectives. Objectives are the things that you are to learn, or you think um, you know, at every stage there are objectives that we should, these are the things that you're expected of to know at this stage. Then we have a task just like he has done. Moving forward, you may not be able to have enough time to whiteboard all the tasks because there are a whole lot. Okay, that was why I brought out, if you look at under this, so for those that are here, you see something called the survey for CLO. Some persons have filled it. It simply means um, in the task and quiz, which one would you want us to whiteboard? Okay, we didn't follow this today, but as you're moving forward, everything will start getting structured. And this was the result. I would have shared this. This was the result. Okay, so many persons wanted us to um, the highest for the quiz. Number 5, question 5 was the one most people wanted to get, understand how it came about. That's for the quiz. And for the task, you can see it here. Number 8 had the
People actually
highest.
responded.
Yeah.
You did show us this. So I don't know.
Yes. I was trying to load it up. Okay. So, but moving forward, we start working with this these things, this kind of metrics. Okay, so for the next to make things very simple and let's flow very well. Okay, so that's just all. So the next concept will be opened, and the next peer learning day. Today is Thursday. No, we actually agreed initially to have a session on weekend and during the weekday. We have one already today. So can we have another one during the weekend?
Yes, of course.
Yeah, I think you can open that. You can obviously say that.
All right.
You will now ask people to obviously volunteer for my contribution.
Yes. All right. So we having one on Saturday. This Saturday or Sunday? I think it's on Sunday, right? Okay, Sunday. If it starts to be on Sunday, it has to be in the evening. So let's talk about this now. Okay, what will happen is I will still throw it on the group.
Sunday.
Sunday, right? Okay, I'll still
You
throw
can
it on
run
the
another poll, to be honest.
yes, I'll throw it on the group and finalize immediately so that we'll have the next peer learning on Sunday for the next concept. Okay, even if you can't finish it on Sunday, we'll finish it sometime next week, early next week. Then go into the next thing, the next new concept. Still next week, like that. We'll keep moving and hoping trusting we are moving forward. So I believe no questions at this point. We have used about an hour 30 minutes. Um, look, I believe no questions, and I believe anybody who's really interested has really joined this link. Um, okay, one more thing I need to stress on, and after that we're done. Now, you'll get to notice that as we're entering new concepts, the materials ALX are providing us, you get to see that some concepts, the materials they're giving us are not really enough for us to really comprehend that concept. So we'll get to those concepts. And now I'm looking at us now, for those who are following the program, okay, and who are trying their best. Now there's a provision for you to suggest materials that you are using, okay, or that you came across that has helped you to understand that strategy. Now, the goal is when you get this kind of material, when you get this kind of materials, either videos or whatever. Now, like I said, you're to share it with the just like others people have been doing on the platform, and that's a very good one. Just that we've not gotten to those concepts yet. When we get there, we are going to handle them. Now, the goal is when we are getting there, you have to share those material with the community, stating, okay, this material is good for this particular concept. It helps you to understand this concept. You can add it to the Google Classroom. Now, the goal is, if you can look at this place. Okay, here is the survey. I'll show you what you are using it to do. The next file you see under it is this recording, the recording of this what do you call it? The recording of this today's section. I'll put it on that here. So anybody who missed this session can come into this place and you see it below here. Okay. And now, if there are other materials that can help us to understand, and even if we don't understand this yellow word very well, if there are other videos or materials, I will add them under this concept. So when we get to those parts, you get to see that there are some concepts like that will need extra materials on. Okay, so please, if you have any materials of such types, please do well and share it so that we can add it for the benefit of your community. So guys, thanks. I appreciate your time. It's a collaborative stuff. It's not one-sided. So we are looking forward to having you on the other side of whiteboarding for us on the other side of the screen, guys. So I think we can end here at this point, right?
Yeah, I think we are good.
All right. So guys, have a nice night and see you on the group. Good night, guys.
Yeah, thank you very much.
All right.
Good night.
Yeah, good night.
Yeah. Thanks, Samuel. You really did a good job tonight. Thank you so much. I appreciate it.